Okay, so this is the last section of that first algebra unit. Okay, so this was all of algebra 1, quite a big chapter, a lot in it, and this is the last section. So we're finally on to solving equations, which is one of the main things you'll see in algebra throughout the course. Big difference here is up until this point we've only been simplifying. So keep in mind when you see simplifying, there's no equals. You're only dealing with expressions, which means you're adding or subtracting like terms. Okay, so adding, subtracting like terms, and we also deal with factorizing in that section. Okay, solving means you're always going to have an equals in your question. You're going to end up with a specific answer, okay? So you're going to have x equals something at the end or y equals something at the end, okay? You'll still use the same principles that you used in simplifying, but you just need to bring it a step further when you're solving, okay? So we might as well start. There's lots of different sections in solving. I'll try to get through all of them in this video, so it might be a lot in it, but we'll try get through as much as we can. So linear equations. Okay, so what we're looking at here is one variable. Okay, so one variable or letter. So at the end of this, you're going to have an x value. Okay, if we look at the first question, we have two x terms. Now I would have done the same here when I was simplifying in the earlier videos. X values are like terms and then the constant is on its own. So the idea here is to have all of the x's on one side of the equals and the numbers on the other side of the equals. Okay, because remember we can only add or subtract like terms, so that's why I'm doing that. So very quickly, I suppose there's two ways we can do this. We can do the same thing to both sides of the equals, which means we're not changing the question and we're balancing the equation. But what you might remember doing is just moving the terms to each side. And when we move the terms, adding becomes subtracting. Subtraction becomes adding. Multiplication becomes division, or division becomes multiplication. So it's the opposite operations here. When we move something to the other side, it becomes the opposite operation, and our operations are adding, subtracting, multiplying, and dividing. So if I was to move the plus 3x to the other side, that would become 5x. And because we were adding on this side of the equals, when we move it over, we're now subtracting. And negative 4 or subtracting 4 moved over to the other side becomes positive 4. So we now have 5x minus 3x is 2x equals 4. Now remember, the idea here is that we get x on its own equal to a number. 2x is the same as 2 multiplied by x. So if I move multiplied by 2 to the other side, it becomes division. So x is equal to 4 divided by 2 is 2. Okay, final answer. Next question, you can see we've worked on this before when we were multiplying terms. So remember, we have to multiply the outside term by every term inside the bracket. So we were using arrows, and I think you used arrows in your questions you were doing. So 2 times x is 2x, 2 times 4 is 8, 6 times 2x is 12x, and 6 times 3 is 18. Okay, so I'm going to underline the 2x and the 12x because they're like terms, and just a little star under the 8 and the 18 because they're both constants, which means they're also both like terms. So I'm going to move, it doesn't matter which side you have the x's, so I'm actually going to, in this example, leave the 12x on the right hand side, and I'm going to bring the adding 2x over to the other side, so we're now subtracting 2x. The plus 8 was already on the left hand side, and I'm going to move the plus 18 over to the other side, so it's now minus 18. 12x minus 2x is 10x. 8 minus 18 is minus 10. Now we want to get x on its own, so this is the same as 10 multiplied by x. So if I leave x on its own and I move multiplied by 10 over to the other side, it becomes dividing by 10. Now careful here with our signs. We've minus 10 divided by plus 10. Remember when we were multiplying out terms, when we're multiplying or dividing, different signs gives us a negative. So remember, minus by minus gives us plus, plus by minus gives us minus. That is the same for division. So a minus and a plus becomes minus, and 10 divided by 10 is 1. Okay, so they're the easiest that you will see, the easiest equations you will see. So we'll just keep moving on, and it gets a little bit more complicated. So same ideas here. We have our brackets that we need to remove. So brackets tells us to multiply. So we're multiplying the outside term by every term inside the bracket. So that will be our first step here. 3 by 2x is 6x. 3 by minus 3 plus by minus is minus, and 3 by 3 is 9. Minus 4 by x minus by plus is minus, and 4 by x is 4x. Minus 4 by minus 3 minus by minus is plus, 4 by 3 is 12, equals 7x plus 7. So notice I haven't done anything with that yet because my first line was to remove the brackets and there was no brackets on this side. So we just have more terms here, and that's why it's just a little bit more complicated. Not that much more complicated, but just a little bit more work involved. So I've underlined my 3x terms and I've put stars under my 3 constants. And remember, the idea is that we'll put the x's on one side and all the numbers on the other side. We can tidy up this left-hand side first of all. So 6x minus 4x is 2x, minus 9 plus 12. So if you're on negative 9 and you add 12, you end up on plus 3, equals 7x plus 7. Now again here, I have an x term on each side and a constant on each side. Now I'm going to leave the 7x on the right hand side, and you'll notice what I'm doing is I'm just keeping the bigger x number on the same side it was, just so we're not getting a negative variable. It wouldn't matter, it just would again involve more work. If I move adding 2x over to the other side, we are now subtracting 2x. Plus 3 was already on the left hand side, and if we move adding 7 to the other side, we get a negative 7, or subtracting 7. So 7x minus 2x is 5x. 3 minus 7 is minus 4. So this one here, it looks like we're going to end up with a fraction. So we have 5x, remember, is 5 times x. So if I leave x on its own, we end up with minus 4 over 5. Okay, and that will happen sometimes that you'll get fractions, unless I've made a silly mistake there somewhere, but it is normal enough to get a fraction as an answer. Okay, so let's look at the next section. So the only difference here is that we're dealing with fractions, so solving linear equations with fractions. I've written here again lowest common denominator, and we would have seen this when we were simplifying in other videos. So lowest common denominator is our starting point here. And just what I always do here, when I have a constant on its own at the end, I always put that over 1, just so we remember that they're all fractions. It's nearly easier to have all of them as fractions. Now, lowest common denominator of 3, 5 and 1. So what we're looking for is the lowest common multiple, okay? So our lowest common multiple would be 15. So we are going to now change our denominator to 15. And we're now going to rewrite the top line using this denominator. So 3 divides into 15 5 times, and we multiply 5 by all of that top line. 5 divides into 15 3 times. Now don't forget the negative that was there, so it's minus 3 times 4x minus 2. And then 1 divides into 15 15 times, and we multiply that by 5. Now once we've used the denominator to alter the top line, our denominator is now gone, our fraction's now gone. And what we have is very similar to what we had up here. So we need to multiply out those brackets. Be very careful with our signs. 5 times 8x, 5 eighths are 40, so 40x. 5 times minus 3 is minus 15. Minus 3 times 4x is minus 12x. Minus 3 times minus 2, minus by minus is plus, and 3 times 2 is 6. 15 times 5, so 5 times 10 is 50, 5 times 5 is 25, so 50 plus 25 is 75. So we have 40x minus 12x, we've minus 15, plus 6, and 75. So I'm going to tidy up that left-hand side first. So 40x minus 12x is 28x. Minus 15 plus 6 is minus 9 equals 75. This negative 9 is going to move over and become positive. So we've 28x equals 75 plus 9. So 28x is equal to 84. And remember, 28x is 28 times x. And if we move multiplying by 28 over to the other side, we end up with division. Okay, and if we look at that on our calculators, 63 eighths, 24, yeah, 84 divided by 28 is 3. Okay, so not that difficult. The only thing that's different from this equation up here is that you needed to find the lowest common multiple or the lowest common denominator. Use the denominator to change the top line, and then you end up with just a standard linear equation to solve. Okay. Now, manipulation of formula also falls under this section. So you're going to be given an equation, and why this is a little bit more challenging is it generally has a lot more variables in it. Okay, so if you see this question here, it says y equals mx plus c, and it says make x the subject of the formula. Now what that means is when you rearrange this, they want you to write the answer as x equals everything else. Okay, so the x has to be on its own on one side of the equals. So all we have to do is move things around, but when we do that, you need to remember your opposite operations, okay? So adding becomes subtraction and multiplying becomes dividing. So for this one here, it says make x the subject of the formula. So I'm just going to underline the term here that has an x in it, and I'm going to move everything else to the one side. So I'm going to move adding c over to the other side, which means we'll now have y minus c equals mx. Now remember, mx is the same as m multiplied by x, and we're trying to leave x on its own here. So if I move multiplying by m over to the other side, we end up dividing by m. So we've y minus c divided by m, and that's your answer. So it doesn't make that much sense, I suppose. But the idea is that they wanted x to be on its own and not y. Okay, so you're following all the same principles as what you already did in solving linear equations. So this one here, express b in terms of a and c. So what they want is the b on its own this time. Now the problem here is that there is a b in two different terms, so it becomes a little bit more complicated. So the first step here is to get the two terms with b in it onto the one side. So 2ab is on the left hand side, and I'm going to move subtracting 3bc over to the other side. But if it was subtracting on this side, when we move it over, it needs to become addition. So 3bc, and we're leaving that 2a on its own here. Now, if you remember in our factorizing video, factorizing using the highest common factor means you have to take out what the terms have in common. And this is the only way we can get b on its own, is by factorizing these two terms. So they have a b in common, and we're left with 2a plus 3c, and that's just equal to 2a. Now remember, brackets are multiplication, and this is b multiplied by 2a plus 3c. So what we do here is leave b on its own. We had 2a on the right hand side, and we're going to put that over, because remember, multiplication, moving it over becomes division. 2a plus 3c. So we've b on its own and everything else on the right hand side. Okay, and the last one of those we'll do, it says here, make a the subject of the formula. Now what we can do here is cross multiply. We have two fractions, and we could cross multiply, which would eliminate the fractions for us. So I'm going to multiply 2 by all of that top line on the left, and 3 by the top line on the right. Now we're trying to get a on its own in this question. So we have 2 times a is 2a, 2 times b is 2b, and 3 times c is 3c. So because this is the a term, I'm going to leave it on its own for the moment. We have 3c on the right, and when we move adding 2b to the right hand side, we're now subtracting 2b. And lastly, we've 2 times a, which means if we leave a on its own and we move the 2 to the other side, the multiplication is now going to become division. And that's exactly as we leave it once we have the variable on its own. Okay. Now, simultaneous equations. Okay, so this time you're going to be given 2 equations, and there's going to be 2 variables this time. Okay, so it could be x and y, it could be a and b, it could be e and f. So it's any 2 variables. But the idea is you need to now solve both variables. Okay, in order to do this, you first need to eliminate either the x or the y to find the value of x or y, and then sub in the value you found to find the other variable. It sounds much more complicated than it is when I show you the example. So the idea here in this first question is that we're trying to either get rid of the x's or the y's. So I treat this as if it's like a primary school sum on top of each other. So if we want to remove either the x's or y's, they need to have the same coefficient. So remember, coefficient is the number in front of the variable, but they must have different signs. Okay, so I can see here x plus x gives me 2x, so I can't eliminate those just yet. Plus 1y minus 1y is 0, so we can eliminate those. It's like having €1 minus €1 is 0, so it's gone. Remember, there's a 1 and a 1 here, so now we're going to treat it like a primary school sum. So 1x plus 1x is 2x, 13 plus 3 is 16, and now we have a linear equation. So to solve this linear equation, remember 2x is the same as 2 times x. So if I leave x on its own, we've 16 on the right hand side. Multiplying by 2 moves over and becomes dividing by 2. So x is equal to 16 divided by 2, which is 8. Now remember, at this point you have to find x and y, and you've only solved these equations to find x. So what we do is we use one of the equations in the question. So like this first one here, x plus y equals 13. But instead of x, remember we did substitution in the very first video. Instead of x here, we're going to replace it with the 8 that we just found. So we now have 8 plus y equals 13, and we're trying to find y on its own. So if we're trying to find y on its own, okay, so if we're trying to find y on its own, it means that we have to move 8 over to the other side. So we were adding 8, and if we move it, we're going to be subtracting 8. So y is equal to 13 minus 8, which is 5. Now, you will not usually be asked to check your answer, but if you were, you could take either of the equations again from the start. We found x was 8 and y was 5. So if we sub those back in, we've 8 minus 5 equals 3, which is 3. Therefore, we have the correct answer. Okay, so that is the simultaneous equations. The easiest example that you will see, but the pattern will still be the same in the other questions. Okay. Next question, we have 2x plus y equals 9 and 3x plus y equals 11. Now, the problem is, if you look at this example, we were able to get rid of the y's straight away because they had different signs and the same coefficient. So here we don't have different signs for either of the variables. So we're going to have to change the signs of one of the lines, okay? Now, if you want to change, say, the sign here to a negative y, you have to change all signs in the equation. So if I change this to a minus y here, then this 3 needs to become minus, and this 11 also needs to become minus. And now we have y minus y, which is 0. 2x minus 3x is minus 1x, and 9 minus 11 is minus 2. So we now have x equals minus 2. Remember, this is minus 1 multiplied by x, so multiplication becomes division. Minus divided by a minus, the same rules as multiplying. Minus and a minus gives plus, and 2 divided by 1 is 2. Okay, once we've found one of our variables, we then need to write down one of the equations in the question. It does not matter which equation you pick. Instead of x here, we're now going to replace it with 2, because x is now equal to 2, so I can replace this x with 2. 2 by 2 is 4, plus y equals 9. Y is equal to 9, and if I move adding 4 over to the other side, we are subtracting, so y is equal to 5. Okay, might just do a quick check there just to make sure we're right. So I'm just going to take the first equation again, 2x plus y equals 9. X is now 2 and y is 5. 2 by 2 is 4, plus 5 equals 9. 4 plus 5 is 9 equals 9, so we're correct. Okay, and the last one. So here we have a little bit more work to do again. We do have different signs here, but we don't have the same coefficient. So we have to have the same number in front of the variable if we're going to be able to eliminate them. So I now need to pick what the lowest common multiple would be between 5 and 4. And we know the lowest common multiple would be 20. So if we got both of those numbers to be 20. Now, we can't just change the one term, we've to change the whole line. So if I'm trying to make this 5 become 20, we have to multiply all of the top line by 4. And if we want to make this 4 a 20, we have to multiply all of the bottom line by 5. So top line becomes 4 by 2 is 8x, 4 by minus 5 is minus 20y, and 4 times 0 is 0. Bottom line becomes 5 times x is 5x, 5 times 4y is plus 20y, and 5 times 13, 5 times 10 is 50, 5 times 3 is 15, 50 plus 15 is 65. And what you should notice here is we have our 20 minus 20y, so plus 20y minus 20y is 0, so we're able to get rid of that. 8x plus 5x is 13x equals 0 plus 65 is 65. Remember, 13x is 13 times x. So if it's times, when we move it over to the other side, it becomes division. So 65 divided by 13, and we know that would be 5. So when we have solved one variable, we need to write down one of the other equations from the start. And we're now going to sub in our x value, x equals 5. So we're going to sub that in. So we've 5 plus 4y equals 13. 4y equals 13. And when we're adding 5 and we move it to the other side, we are going to subtract 5. 4y equals 13 minus 5 is 8. Y is equal to 8. Remember, 4 times y becomes 8 divided by 4. So y is equal to 2. They can be challenging. People tend to find them difficult. So again, when you're practicing those questions, you might want to watch back the part of the video, or maybe pause the video as you're doing the questions. But they need plenty of practice for sure. Okay, and they are asked very, very regularly. Okay. I think this is the last section. Yeah, so we might as well finish and do the inequalities. So linear inequalities. First of all, you can see there's not going to be an equal sign here because it says inequality. So unequal. So there's no equals in these questions, but there will be our symbols that we probably recognize. Okay, so this symbol here, okay, is 7 is greater than 5. So this is our greater than symbol. Okay, this symbol here, we have 3 is less than 8. Okay, and here when we're looking at algebra, this is going to be x is less than or equal to 4. And this one here is x is greater than or equal to 7. Okay. N here means our natural number lines, which means natural numbers starts at 1. Okay, they're positive whole numbers. So it starts at 1 and is infinite, so it goes on forever. Z is our integers. Now integers are positive whole numbers, negative whole numbers, and 0. Okay, they're also infinite in both directions, hence the ... dots. Okay, and or is our real numbers. Okay, and real numbers is literally everything. You're talking about fractions, square roots, everything. Okay, now why this is in this chapter is we're going to treat these inequalities exactly as we would treat the equations. So it's the same principles when you're moving operations to other sides, okay? You're going to see this at the end of the question, okay? Just ignore that for the moment and we'll just work out the question. So first of all, we 4x minus 4 is greater than or equal to 8. So we're going to imagine that's an equals and we're going to do everything that we would have done in the start of the video. So I'm going to leave 4x on the left on its own is greater than or equal to 8. And when I was subtracting 4 on the left, when I move it over, we're going to be adding 4. So 4x is greater than or equal to 8 plus 4, which is 12. Remember, 4 times x, and when we move times to the other side, it becomes divided by 4. So x is greater than or equal to 12 divided by 4 is 3. So this is your answer. And what they might do is ask you to write down the first 3 numbers of this set. So if x is greater than or equal to 3, it means it could be 3, 4, 5, and any number above that. Okay. Next question. 5x is less than or equal to minus 2. When we move adding 3 over to the other side, we are subtracting 3. So 5x is less than or equal to minus 2 minus 3 is minus 5. 5x is the same as 5 times x. So x is less than or equal to minus 5 times becomes division. So it's divided by 5. So x is less than or equal to minus 5 divided by 5 is minus 1. So what we're looking at here, if it's less than or equal to minus 1, it means the number could be minus 2, minus 1, and infinite, but to the left, if you get me. Thinking of our number line there. Okay. Now, the last set of questions, okay, we've 3x minus 8 is greater than 4. Okay, we look at this at the end. 3x minus 8 is greater than 4. So we're going to leave 3x on the left is greater than 4. Minus 8 moves over and becomes adding 8. So 3x is greater than 4 plus 8 is 12. X is greater than 12 divided by 3. So x is greater than 4. Now, greater than 4, okay? That means it can't actually be 4 itself. It doesn't say greater than or equal to 4. It just says greater than 4. So what we're looking at here is technically it could start at 4.1, 4.2, 4.3. But for the moment, we'll just say 5, 6, 7, ... Okay, we will go into more detail later. Okay, so here we've brackets that we need to remove. So we've 2 times x is 2x. 2 times 2 is 4, is less than or equal to 5x minus 2. Okay, so we now have x's on both sides and numbers on both sides. So I'm going to leave the 5x here because it's the bigger number. I'm going to bring adding 2 over to the other side. So we're now subtracting 2x. 4 was already on the left and it was positive. And we're going to bring negative 2 to the other side, or subtracting 2, so it becomes adding 2. So 5x minus 2x is 3x. 4 plus 2 is 6. 3x is the same as 3 times x. So if we move that to the other side, it becomes division. Just going to move over here. So we've x is greater than or equal to 6 divided by 3 is 2. Okay, so greater than or equal to 2 means it's allowed to start at 2, 3, 4, and so on. So the last part we're going to look at, okay, multiplying out the brackets. So we've 4 times 3x is 12x. 4 times 1 is 4. 2 times x is 2x, and 2 times minus 3, plus by minus is minus. 2 times 3 is 6, plus 9 is greater than or equal to 0. So we have constants and x terms here. So I've underlined the x terms. 12x plus 2x is 14x. 4 minus 6 is minus 2. Minus 2 plus 9 is plus 7, is greater than or equal to 0. 14x is greater than or equal to, adding 7 becomes 0 minus 7. 14x is greater than or equal to minus 7. Remember, 14x is 14 times x. So we've x is greater than or equal to minus 7 divided by 14. So x is greater than or equal to minus a half. Okay, and on our number line, greater than or equal to minus a half means starts at minus a half, 0, 1, or whatever, so on. Okay, I will go into a bit more detail. Actually, just to notice there, okay, I thought it was a real number, but it's actually an integer. So this is actually wrong. Because this is an integer, integers are only whole numbers, and a half or minus a half is not a whole number. So greater than or equal to minus a half means the first whole number that it can be would be 0. I'm not sure if it'll go into that much detail for you, but that's something to watch out for. That's a whole number, and your answer here was a fraction. Okay, so quite a lot in those questions, and quite a long video, so it's going to take you some time to go through it. Maybe stop and start after each section and maybe try the questions as you're going through it. I'm going to send you on a list of questions based on all of that video, and I'm also going to send you on some revision questions, which will be based on the full chapter that we've done so far, and we'll go from there. Okay.